A very good evening to Dr. Ganesan. I am Sarah Imani. I am from Group 1. We're going to talk about electric guitar. My part is introduction part. Introduction. Electric guitar utilize the concept of Faraday's law and magnetism concept. The electric guitar have device called pickup placed underneath magnetic guitar string. These pickups are wire coils with 4,000 to 7,000 turns. When magnetized string is plugged, it vibrates like a magnet. The magnetic flux through the coil changes, inducing EMF through the coil. Electric signal produced in amplifier. The equation is EMF equal to negative of magnetic field.
Hi, my name is Nur Faiza. Next, I will continue about the Faraday's law of induction. Okay, Faraday's wonder is, could you take a magnetic field and produce the current from it? So Faraday's conduct an experiment using the coil carrying current, and he moved the magnet toward the current, and he found that magnetic field in the coil is increasing. And after that, he moved the current away from the coil. Then he found that the magnetic field in the coil is decreasing. And if there are no movement of the magnet, the magnetic field in the coil is stay constant. So Faraday concluded that a changing magnetic field can produce an electric current. So he also found that the more rapidly the magnetic field change, the greater the induced EMF. Induced EMF depends on the area of the circuit loop. Magnetic field magnetic flux equal to vector of magnetic field dot vector of area. And if the field is non-constant, the magnetic flux is equal to double integrations of surface vector of magnetic field dot change in vector of area. From the result of induced EMF, the induced EMF is proportional to the negative of the rate of change in magnetic flux. This equation. For the coil contain N loop, EMF is equal to negative N, which is the number of loop, change rates of change in magnetic flux. That's all from me. Thank you.
Shazana binti Osman will explain how electric guitar work. Firstly, bar magnet and pickup generate a magnetic field around it. The number one is the bar magnet, which is in black color. Secondly, magnetic field extend invisibly upward through the metal guitar string above the pickup. The magnetic field is here. Magnetic field here. Third, guitar string near the magnet become magnetized by the magnetic field. As it vibrates, it makes a changing magnetic field of its own. The red line indicates the guitar string. Thin wire wrapped around the pickup detects pickup. The field degenerates, induce a tiny electric current in the coil. So this one, which in orange color, is the coil of tiny wire. Amplifier boosts electric current, making a larger current big enough to drive a loudspeaker. This is the amplifier. 6. Loudspeaker turns electric current into sound. So this is loudspeaker, which turns electric current to sound. Thank you.
We'll be talking about our electric guitar and its problem, how we can solve it. Okay, so we can see here, this is the string of the guitar, which is magnetized. And this is the pickup of the guitar. And as you can see, the pickup is coiled with a wire, and this string is magnetized, as you see. Okay, so we need to see that how the pickup. Okay, we need to see how the electric pickup picks the vibration from the string. The pickup is with 200 turns and with an area of 5 cm square. So what is the EMF induced? As we know, EMF is the change in magnetic flux over time. Right. Since there's a number of turns of the pickup, we use to multiply the number of turns with the change of the magnetic flux. As you can see that the angle between the pickup and the string is at 90 degrees. So after that, it's just straightforward. So we can solve this problem. So you can just substitute all the value of 200, where the change in magnetic flux is about as you can see that I forgot how to write the number of the magnetic field, which is 0.02 Tesla. We can just substitute the value, which is 0.02, and the area is 50 times 10 to the power -4, with cos 90 over change in time. Let's say the time is about 10 seconds. So you can just calculate the induced EMF. We'll get about 2 times 10 to the power 3 volts. So that is how we solve this kind of questions. So let me show you again, where the string is magnetized, which will induce a change in the magnetic field of this pickup, which in turn is coiled with a wire. So it will induce an EMF, and the angle is 90 degrees. So thank you.
Hello, my name is Nur Shima binti Mamahata. Today, I will share a calculation about intensity in electric guitar. So this is the question. An electric guitar amplifier is at a distance of 5.7 meter. Find the intensity of its sound wave when its power output is 0.3 volt. Answer in unit of volt over meter square. So for this question, I will use the formula of intensity equal to power over area. So for the area is 4 pi radius over 2. The value of the radius, I will put the 5.7 meter, and it will give a value 35.81 meter square. So by using this formula, I will put the power of the sound 0.3 volt over 35.81 meter square. And the final answer is 8.38 times the 10 the power of negative 3 volt over meter square. That's all from me. Thank you.
Hi, my name is Lily binti Abdul Malik, and today I'm going to make a conclusion of electric guitar. So, for the first one, we know that electric guitar is different from other guitar, which the other guitar they only vibrate to make a sound. But for electric guitar, it utilizes the concept of Faraday's law as well as the other concept related to magnetism. So as we know that in electric guitar, in the board itself, they have this one thing we call pickups, and then when the magnetized string is plugged, it vibrates like a little magnet, and it changes the magnetic flux going through the coil, inducing an EMF through the coil, and after that they're producing an electrical signal in the amplifier. So that's how we hear the the noise from the guitar made. So that's how basically electric guitar works. So that's all from my present. Thank you and have a good day.